Hey everybody, so I wanted to do one of the problems here that had matched pairs. So matched pairs is a very important kind of study. Basically, we're following the same person or people that we think should be paired together. I often propose a question like, couples are the same height, and that's a matched pair kind of question. We have our matched paired data here. I do not think I'm going to be able to copy and paste this data. It's just the way it's an image here. So I'm going to transfer it over, but I'm going to pause while I do. Okay, I have my data transferred over. Sorry, that's not the most interesting thing to watch, I don't believe. So here's what I'm going to go ahead and do is I'm going to go ahead and do the difference of this data. So remember to do the difference. It's just subtraction. So I'm subtracting A1 from A2, and I'm kind of lazy, so I like to just do it all at once. There you go. Boom. Those are all the differences from X to Y in this paired sample data. So let's see what the average of that is. The average of that data is 4.71, and we expect there to be no difference between those two. So let's go ahead and take this. This is that first question here. Control V. There you go. Let's check. Want to make sure we get that right. Boom. We got that first part right. Okay, so next part is we need the standard deviation. That's why it's really nice to do this in Excel. So STDVE, and this is dot S. Always use the sample standard deviation because this is a sample after all. So 12. Standard deviation is always positive, even if you give it negative answers. Let's check that one too. Still on task. Good. All right, so the next thing is we have to do a t-statistic. So this is the first video where I've actually come up against a t-statistic. So the t-statistic is t.dist. Actually, let's go ahead and do, sorry, before I do the t, let's get a formula for how you compute the t here, because I'm actually just going to compute the t. So the t is like the normal distribution. I said that right. Where you're going to do the sample minus the mean. So let's write it out here. We're going to do the x bar, which we computed, minus the mu. And we're going to divide by the SE. What's different here, the only thing that's different in this whole computation is that the SE here is a sample standard deviation, an S divided by the square root of N. So this is really, really similar to everything else we've done. The only difference here is that the sample standard deviation instead of a population standard deviation. And when that happens, you have to use a different statistic, believe it or not. So that's a little weird that I have to use a different test statistic, but that is part of the challenge in statistics. And this is actually where statistics goes for people. By the way, the sample size is 1, 2, 3, 4, 5, 6, 7. So I'll do the square root of 7 to get the SE. And so this number is this minus 0, which is totally unnecessary, but I did it, divided by the standard error. So exactly like I would have computed the Z, except now I call it a T. So I hit check again, I got that one right too. Okay, so I need to figure out the critical, the positive and the negative critical value. The interesting thing here about the t-statistic is it requires a second parameter. I showed you guys that the n was 7, right? When I try to take a t and compute, like we were doing before, norm.dist or norm.inverse, there's a t.dist. And so actually I need the t.inverse. It asks for a probability, And so if we want a 99% confidence interval, again, we want one of the tails, so I'm going to do 0.995. But the t requires this thing called degrees of freedom. And the degrees of freedom is the sample size minus 1. So all you have to do for that is you have to do the sample size minus 1. Now this is not required in the z statistic, in the normal distribution, but it is part of the t distribution. So here's my positive critical value. And I will tell you guys that the the t is perfectly symmetric. So if you need the negative critical value, it's just the minus of that. So let's check those answers, make sure I'm still on task. If I wanted to do that computation through Excel, I would have done the t dot inverse, and when I would have given it the probability, I would have given it 0.005. I wanted a half a percent less than. And again, I got to give it the degrees of freedom. That's the sample size minus 1. You see that gave me the same value, maybe rounded, because it can't display that. So it asks, does the statistic fall in the critical region? Well, no, it falls in between those. All right, so then I want to construct the 99% confidence interval for the difference of the for the interval of the population mean for all of the differences. So let's do that. We've got our t value here, our t star, critical values, and so again, our confidence interval, we do the statistic minus the t star this time instead of the t times the SE. And we'll do our statistic plus the t star times our SE. So only a little bit changes here, but it can be a little tricky. So there's our confidence interval. I'm just copying and pasting. Whoops. All right, and we'll check. There we go. I'm all right. Okay, so I had to put the data in manually. I subtracted the differences in the data. I compute the mean and the standard deviation. Then I'm going to use a t-statistic, but a t-statistic ends up being very similar. You do the x bar minus the mu, you divide by the SE. SE is the sample standard deviation divided by the square root of n still. The t-statistic still requires it's t dot inverse, or if you want to do the probability, it'd be t dot dist. And you got to remember to include the degrees of freedom, which is the sample size minus 1. So really the only new thing here is we're calling it t, and you got to remember to do the sample size minus 1. Otherwise, these are very similar to all the ones with the normal, just a little trickier. All right, keep studying hard.